In section 6, we're going to talk about ratios and proportions. So by the end of this lesson, you should be able to compare ratios, and then you should be able to solve proportions. So a ratio is a comparison of two numbers by division. And if we have the ratio of two numbers, we can say the ratio of x to y with the letters TO in there. We can say the ratio of x to y with semicolons in there. Or we can say the ratio of x to y with a division bar in there. This is our most favorite way. That's the way we use the most. The other thing we're going to talk about today is an equation that states when two ratios are equal, and that's called a proportion. So let's just talk about ratios first. Equivalent ratios are two ratios that are equal when they're written in the simplest form. So you'll get problems like this where it just says to determine whether each pair of ratios are equivalent. We just have to write yes or no and then justify our answer. So you can do this a couple different ways. Because ratios are written as fractions, you can just simplify your fractions. So when I look at 6 over 10, I try to find a number that goes into both of these. And since 2 goes into both of them, 2 goes into 6 3 times, and it goes into 10 5 times. So 6/10 is the same thing as 3/5. And then my other one is 2/5. And since this is as simple as possible, these are the two things I'm comparing. And they're not the same. So these are not equivalent ratios. The other thing that you could do if you have a calculator is type these into a calculator. 6 over 10 is 0.6. And 2 over 5 is 0.4. Since these are not equal, they're not equivalent ratios. So same thing with this one. 1/6 is as simple as possible, but 5/30 is not. So you find a number that goes into both of them, and since it's 5, you end up with the same thing. And if you type 1/6 into your calculator, you get 0.16 repeating forever and ever. And if you type in 5/30, you get exactly the same thing. So another reason to write yes. So I don't really care which way you use. They're both good ways to figure this out. So remember what a proportion is. It's an equation stating that two ratios are equal. There's special names for the terms in a proportion. So you have means and extremes. Means are the two middle numbers when it's written this way, and extremes are the two end numbers. Now remember, if we were to write this as a fraction, it would be 0.2 over 1.5, and then that equals 1.2 over 9.0. So when it's like this, these guys are your extremes, and these guys are your means. So basically, all you need to get from this is that we have a property. In a proportion, the product of the extremes is equal to the product of the means. So that if you have something like this, we can find cross products, and we know that they have to be equal. So we had done this once in class, but let's say I gave you the fraction, let's do 2/5. And I wanted to set this equal to another fraction. If I put this over 10, hopefully everybody knows that that means I multiplied this by 2, so I'd have to multiply this by 2. So 2/5 and 4/10 are exactly the same. This property says that if I multiply these guys together, 2 times 10, that it should give me exactly the same thing as if I multiplied these guys together, 4 times 5. And it does. It gives me 20 for both of them. So we can use that to solve problems like this. Use cross products to determine whether the ratios form a proportion. So remember, a proportion is saying that the ratios are equal. So this is one more way that you can determine whether or not two ratios are equivalent. So you're trying to ask yourself, are these two things equal? So just like the problems back here, you could type them both in your calculator and see if you get the same thing out. You could simplify them to see if you get the same thing out. But because it asked us to use the cross products, that's what we have to do. We need to multiply these guys together. So 2 times 14, we need to know if that equals 3.5 times 8. So 2 times 14 is 28. And if you type this into your calculator, you also get 28. So because these two things are equal, then you know these ratios form a proportion and that they are equivalent ratios. Try this one on your own right now. So the other reason we need cross products is to solve proportions. If I give you something like this and I ask you to find out what's missing. Now, some of the problems are going to be incredibly easy, and chances are you can do it without using cross products. If you look at these denominators here, you can see that there's a relationship that if I multiply 8 times 5, it gives me 40. So then you want the same thing here. So what number would you have to multiply by 5 to give you 25? And you would get 5. Remember, you're trying to make these equal to each other. If you would like to use cross products like we just learned, all you got to do is multiply the numbers together, 8 times 25, and set them equal to your other cross product, r times 40. And then you just have a nice pretty equation to solve. If we divide both sides by 40, we still end up with 5. Now, of course, not all of them are going to be as easy as that one, where you can kind of cheat without using the cross products. Like if I go from here to here, there's not really a number I can think of off the top of my head that if I multiply by 5, I'm going to get 8. So our best solution path here is to multiply our cross products together. So 5 times 3 has to be equal to 8 times x plus 4. Now, it's really important to put these parentheses here because this 8 needs to multiply by everything on top there. So then we just solve it like the equations that we were solving before. Get rid of your parentheses here by distributing. All of our x's are already contained on this side, so I'm going to subtract 32 over here. And if I divide both sides by 8, I end up with that missing part is 17/8. And if you wanted to, you could change this to a mixed number. It'd be 2 1/8. Or you could even type it into your calculator and you would get 2.125. Any of those three answers are totally acceptable. I would personally leave this first one because it's less work. So let's try a story. On a model airplane, the scale is 5 centimeters equals 2 meters. So this means you have a mini airplane where every 5 centimeters on the mini airplane is really 2 meters in the real life airplane. If the wingspan of the scale model, so the little one, is 28.5 centimeters, what's the actual wingspan of the plane? So the first thing you got to do is take the information they gave you and turn it into a ratio. So we have the scale and the actual. They tell us that 5 centimeters on the scale is exactly the same thing as 2 meters on the actual one. And then they give us a bit more information that says the wingspan of the scale model, so still on the top because we're talking about the scale model, is 28.5 centimeters. I need to know the actual wingspan. So if I don't know something, I'm going to make it a letter. So you can skip the units in here. And this is what we're trying to solve. And now it looks like just the other problems we were doing. So find your cross products. 2 times 28.5 equals 5 times x. 28.5 is going to give me 57 times 5x. And then if I take both sides and divide them by 5, I'm going to end up with x is 57/5. Now remember, this is something in meters, so this number doesn't make sense for this, although you could leave it. But for this one, I would definitely suggest typing it into your calculator. Even if you converted it to a mixed number, you would get 11 2/5, which is 11.4 meters. So you should be able to compare ratios and then solve some proportions. So I gave you two problems to do here, and then you have the other problem that I left for you to do. Make sure you write down any questions you have, and we can go over them in class tomorrow. Enjoy your night.